Did you know that a tiny piece of matter can release enough energy to power entire cities? Or wipe them off the map? Atomic energy, also known as nuclear energy, is one of the most revolutionary and controversial discoveries of the 20th century. Its power is so immense that it has the potential to change the future of humanity, for better or for worse. In today's video, we're diving deep into one of the most misunderstood and important topics of our time. Whether you're a science enthusiast or just someone trying to understand the world around you, this video will change how you think about energy, technology, and global security. Because truly understanding what atomic energy is, how it works, how it helps, and how it can harm, can make you more informed, more aware, and maybe even more hopeful. We're not here to tell you whether nuclear energy is good or bad. We're here to show you the science, the facts, and the reality, so you can decide for yourself. We'll break down what atomic energy is, how it was discovered, how it powers homes and hospitals, and how it also fuels weapons of mass destruction. We'll talk about nuclear reactors, medical breakthroughs, global conflicts, environmental challenges, and even space missions, all connected by the same powerful force, the atom. But first, to understand its global impact, we need to go back to the very beginning. What is atomic energy? To understand atomic energy, we have to go deep, all the way to the nucleus of the atom. An atom is the smallest unit of matter. It's made up of a nucleus, with protons and neutrons, and a cloud of electrons orbiting around it. Atomic energy comes from manipulating that nucleus. And there are two main ways this happens. 1. Nuclear fission. This is when the nucleus of a heavy atom, like uranium-235 or plutonium-239, is split into smaller parts, releasing a huge amount of energy. This is the process used in most nuclear power plants and in atomic bombs. 2. Nuclear fusion. This is the opposite. In fusion, two light atomic nuclei, like hydrogen, merge to form a heavier one, also releasing energy. It's the same process that powers the sun. While not yet commercially viable, fusion is seen as the future of clean, limitless energy. Both processes release energy because some of the mass is converted into pure energy, according to Einstein's famous equation, E equals mc squared. Energy equals mass times the speed of light squared. This means even a tiny amount of mass can produce an enormous amount of energy. And that's the key to why atomic energy is so powerful and so dangerous. The story of atomic energy begins in the early 20th century, with groundbreaking discoveries in physics that forever changed how we understand matter and energy. It started with scientists like Henri Becquerel, Marie Curie, and Ernest Rutherford, who were studying radioactivity, the natural emission of energy from certain elements. Then, in 1938, two German scientists, Otto Hahn and Fritz Strassmann, succeeded in splitting a uranium atom in the lab. This was the first successful nuclear fission experiment. Shortly after, physicists Lise Meitner and Otto Frisch correctly interpreted the results. The atom's nucleus had been split into two, releasing a massive amount of energy. It was a revolutionary discovery, and it came at a time when the world was on the brink of war. Fearing that Nazi Germany might weaponize this new science, the United States launched the Manhattan Project, a top-secret military program to develop nuclear weapons. Brilliant scientists like Robert Oppenheimer, Enrico Fermi, and Niels Bohr took part, driven by both fear and urgency. The result was devastating. In 1945, two atomic bombs were dropped on the Japanese cities of Hiroshima and Nagasaki. The destruction was unimaginable. Hundreds of thousands of people died, many instantly, and many more suffered from radiation for years. This was the beginning of the atomic age, a moment in history when humanity realized it had the power to end itself. From that point on, the world understood that the energy locked inside atoms could be used not just to build, but to annihilate. But the same discovery that brought destruction also opened the door to peaceful applications of nuclear technology. In 1953, U.S. President Dwight Eisenhower addressed the United Nations with a proposal called Atoms for Peace. The goal was to shift the focus from military to civilian uses of atomic energy, for electricity, medicine, agriculture, and scientific research. This marked the birth of the first civilian nuclear reactors, designed not to destroy, but to produce clean, controlled energy for society. Countries like the United States, France, Russia, and Japan began investing in nuclear power as a way to meet growing energy demands. But even as science advanced, so did fear. With each new discovery came new questions. Could we truly control this power? What if something went wrong? Were we creating a solution or a ticking time bomb? While the dangers of nuclear energy often make the headlines, there's another side to this story, a side that has quietly improved the lives of millions of people around the world. When used responsibly, atomic energy has the power to solve some of the biggest challenges we face today. Let's explore how this extraordinary force has been used for good. 1. Clean and consistent electricity. One of the most well-known uses of nuclear energy is generating electricity through nuclear power plants. Unlike fossil fuel plants that burn coal or gas, nuclear reactors do not emit carbon dioxide during operation. This makes them a source of clean energy in terms of greenhouse gas emissions, a crucial factor in the fight against climate change. Another major advantage? Nuclear energy doesn't depend on the weather. Unlike solar or wind, it runs 24 hours a day, 7 days a week, offering reliable and continuous power. Today, about 10% of the world's electricity comes from nuclear power. In countries like France, that number is over 70%. 2. Medical breakthroughs. Cancer treatment and diagnostics. Nuclear science has also made a huge impact in medicine, especially in the diagnosis and treatment of cancer. Through radiotherapy, doctors use carefully controlled doses of radiation to destroy cancer cells without surgery. Radioactive isotopes are also used in medical imaging, such as PET scans, to detect tumors and other health issues early. Millions of lives have been saved thanks to nuclear technology in medicine, and this field continues to grow every year. 3. Agriculture and food safety. Atomic energy isn't just for hospitals and power plants. It also plays a role in how we grow and preserve food. Radiation can be used to sterilize food, eliminating bacteria and parasites without changing its taste or nutritional value. This helps extend shelf life, especially in countries where refrigeration is limited. Another method, known as the sterile insect technique, uses radiation to sterilize male insects. When released into the wild, they can't reproduce, reducing pest populations without harmful pesticides. 4. Space exploration. Few people realize that nuclear energy has helped power some of our most ambitious space missions. NASA's Voyager spacecraft, still traveling through space more than 45 years after launch, is powered by a small nuclear generator. So is the Mars Curiosity rover and other deep space probes, which rely on nuclear energy when sunlight isn't available. In space, where solar power isn't always an option, atomic energy can mean the difference between mission success and failure. So, while nuclear energy is often viewed as dangerous, it has quietly become a tool for healing, discovery, and progress. It has helped us light up cities, save lives, grow food, and reach the stars. But with great power comes great responsibility, and when that responsibility is ignored or mismanaged, the consequences can be catastrophic. As we've seen, atomic energy has the potential to bring enormous benefits to humanity. But that same power, when misused, mishandled, or left unchecked, can also unleash devastation on an unimaginable scale. History has already shown us what happens when nuclear energy escapes our control. 1. Nuclear disasters. Chernobyl and Fukushima. Let's start with two of the most infamous nuclear accidents in history. In 1986, a safety test gone wrong at the Chernobyl nuclear power plant in the Soviet Union triggered a massive explosion and fire in one of the reactors. A radioactive cloud spread across Europe. Dozens of workers died within days, and tens of thousands of people were exposed to harmful levels of radiation. Entire towns were evacuated. Forests, rivers, and animals were contaminated. To this day, the area around Chernobyl remains one of the most radioactive places on Earth. Fast forward to 2011. A massive earthquake and tsunami hit the Fukushima Daiichi nuclear power plant in Japan. Despite modern safety measures, the reactors were severely damaged, and radioactive water leaked into the Pacific Ocean. Thousands of people had to leave their homes. The cleanup effort has already cost hundreds of billions of dollars, and it's still ongoing. These disasters serve as chilling reminders. When nuclear safety fails, the consequences last for generations. 2. The threat of nuclear weapons. But perhaps the most terrifying aspect of atomic energy is its use as a weapon. Since the bombings of Hiroshima and Nagasaki in 1945, the world has lived under the shadow of nuclear war. During the Cold War, the United States and the Soviet Union stockpiled tens of thousands of nuclear warheads, capable of destroying the planet many times over. Though arms control treaties have reduced those numbers, nuclear weapons still exist, and the threat remains. Countries like North Korea continue to develop and test nuclear bombs. Tensions between nuclear powers can escalate in moments. And the greatest fear? That a nuclear weapon could fall into the hands of a terrorist group, a rogue nation, or even be launched by mistake. One wrong decision, one act of aggression, and the entire world could face irreversible consequences. 3. Nuclear waste and long-term risks. There's also a quieter, slower danger: radioactive waste. Every nuclear power plant produces waste that remains dangerously radioactive for thousands of years. Storing this waste safely is one of the biggest unsolved challenges of the nuclear age. Most of it is kept in underground facilities, sealed away in special containers, but no one can guarantee that they'll stay secure for millennia. And this raises serious ethical questions. Are we creating problems today that future generations will be forced to solve? Are we leaving behind a toxic legacy in the name of progress? Nuclear energy offers great rewards, but the price of failure is far too high. It demands constant oversight, scientific integrity, and international cooperation. It is not a technology we can afford to misuse, neglect, or take lightly, because once the atom is unleashed, there's no going back. Throughout this video, we've explored the two faces of atomic energy, a force capable of healing the world or destroying it. We've seen how it powers cities, treats cancer, protects crops, and drives space exploration. And we've also seen how it can poison ecosystems, leave entire regions uninhabitable, and threaten all of human civilization in the blink of an eye. So where does that leave us? It leaves us at a crossroads. Because atomic energy, at its core, is neither good nor evil. It is a tool, and like any tool, its impact depends entirely on who controls it and how it is used. Science has given us the knowledge. Technology has given us the capability, but the moral decisions, those are still up to us. Will we choose to invest in safety, sustainability, and peace? Or will we continue to walk the line between progress and destruction? This is not just a question for politicians or physicists. It's a question for all of us, as citizens, as voters, as human beings. Because the consequences of nuclear decisions ripple far beyond borders, and far beyond our lifetimes. Today, as we face energy shortages, climate emergencies, and rising global tensions, atomic energy could play a key role in building a better future. But only if we handle it with wisdom, transparency, and global responsibility. The atom is powerful, but the true power lies in our choices. So let me leave you with one final question. Are we ready to control this power? Or will it end up controlling us? If this video helped you see atomic energy in a new light, please share it. Knowledge is the first step toward responsibility and toward change. Leave your thoughts in the comments below. Do you believe nuclear energy is the solution to our energy crisis? Or do you think the risks are too great? Don't forget to subscribe to Kpullo's Things for more videos where science, society, and curiosity come together. See you tomorrow with a new topic that might just change the way you see the world.